All right. Okay. So the arithmetic series. Um, let's refer to this as Gauss's homework. When he was 7 or 8 years old, he was asked by his teacher to add up all the integers or the natural numbers from 1 to 100. So that means 1 plus 2 plus 3 plus 4 plus all the way up to 100. And right away, after a couple of seconds, he answered his teacher, okay, it's 5,050. So how was he able to do that within seconds? Well, as I told you last week, you do have to add up all the numbers, but you can choose the order in which you do so, right? Because this is a sum, so it doesn't matter which way you order it. So that means you're allowed to start with 1 plus 100 if you want. You can continue with 2 plus 99 plus 3 plus 98. I mean, so that should amount to the same thing, right? And it turns out that this is a very good idea because 1 plus 100 is 101. 2 plus 99 is 101. 3 plus 98 is 101. And how many times do you have to do that? What is the last pair? The last pair is going to be 50 plus 51 because that also adds up to 101. So you have 101 multiplied with 50, which is 5,050. So easy peasy once you figure out that little trick. Um, and I mean, that was that wasn't difficult to understand, is it? No. So this is a very good introduction to this. It's a very intuitive way of remembering the formula that we're going to introduce now. Because generally this is true. If you want the sum of a arithmetic series, okay, you take the first term, 1, and you add that to the last term. So u1 is the first term, and un is the last term, because you have n terms in the series. And then you multiply that, not with the number of terms, but the number of terms divided by 2. So we have 100 terms, that's why we multiplied with 50. So now, generally, we take the number of terms and divide by 2. We could test this to see if it works. Okay, add together integers from 10 to 20. Okay, the series for that would be, well, how many terms do we have? From 10 to 11, how many terms? So 10, 11, 12, and so on. No, it's a trick question. It's 11. Yeah. So we take 11, divide by 2. First term is 10. The last term is 20. and we get, what is that, 5.5 multiplied with 30. Yeah. If you don't want decimals, you can always write this as 11 multiplied with 10 plus 30 divided by 2. So starting over from here, you don't divide 11 by 2, you just keep it like this. And that might make life easier because this is, oh, sorry, should say 20. 10 plus 20. Because this is 11 multiplied with 30 divided by 2, which is 330 divided by 2, and that's 165. So 10 plus 11 plus 12 plus so on, all the way to 20 is 165. So it's much easier to use this formula. A little bit about sigma notation. This is dreaded by students all over the world. But it's you know, it's kind of nice. So let's start with the definition of a series. A series is the sum of a sequence. So if you have a series with n terms, that is the sum of u1 plus u2 plus u3. So these are different terms, and you keep adding them up until you have the last term. Now, sigma notation is used as a shorthand for this. So instead of writing all these plus signs, we use this symbol, and it's a Greek S, and the S stands for sum. So what this means is, okay, we sum up all the u's. And to show how many u's we have, we write an index for the first number. So, okay, we want all the u's from the first one, 1, and all the way to n, for example, if you want a general expression. And then you have to index this little u here. So I want this u to have the index I. And the value of I can change from the lowest number to the highest number. So we always write the lowest value here, lowest value of I, and we write the highest value on top. Let's look at one example. If I okay, I'll use one more example without numbers. But I want the sum of all u's from 2 to 4. So I want to sum up the terms, the second term, the third term, and the fourth term. So that is what this means. This means I want to sum up u2 plus u3 plus u4. we could use an example from the tasks that we looked at before. Task 5i3. For example, the first one. So if I want to write the sum of the series n squared, and instead of I now, I can use n under here and say that, okay, n is going to be from 1 to 3. So that means, okay, I sum up these numbers, 1 squared plus 2 squared plus 3 squared, which is 1 plus 4 plus 9, which is 14. So we read this notation here as the sum of all terms n squared from the first term in that sequence to the third term of that sequence. So this is u1 plus u2 plus u3. 1 plus 4 plus 9 is